Hello there. Today we're going to look at Conway's Game of Life, and I might make a separate video on explaining what it is, but let's take a look what it looks like. Hopefully that's coming out all right in the recording. Yeah, based on, I'm just going to summarize the base. There's a world of cells, and based on a few rules, 3 or 4 rules, it is determined that from one step to the next, if the cell is alive or dead. And it just makes for some very interesting patterns and structures. So it is called a game of life, Conway's Game of Life, after the person who invented it. And yeah, I like what I did here. I can easily change the size of the world. I can easily make it full screen. We'll see that in the code. And what else? You could change the colors easily. And so far, it's just on Linux for this video. Code will be on GitHub. And I'll probably soon be maybe making sure that there's a Mac version that works and a Windows version that works. And so let's see here. I've got I've got this run linux.sh that I'm using for it. So today we'll just have a look at the code here and see what's up. It does get a little convoluted and complicated, you might say. There might be some things I need to change. This is kind of a preliminary video, but we'll run through some things pretty quickly, including some of the kind of standard libraries, and then this is not being used. This is a image library not being used, but I just leave it there. And let's see, we'll try to get into the meat of it a little faster, but we've got some macros that are, well, these are not options, these are defining true and false. These are some options. This is should really actually not even be there. I'll put it as false for now. It's kind of left over. I need to clean up the code. In fact, well, yeah, let's get into it. We've got the cells. We've got a struct called cell up here. So it has an int xy, int is alive, so we can see if it's alive or not. Ivec2, that's another struct. So I've got a vec2 struct for floats, got an ivec2, and this is kind of GLSL style. That's the OpenGL shader language style. But anyway, yeah, so it's fairly simple. The trans is meant as transform, I believe. So it just has the X and Y, and I forget exactly why I do that. But we'll see. It's because sometimes I want to pass it as a ivec2 struct. Yeah, anyway. Again, some code that's not really getting used, but I haven't taken it out yet. And we've got these CGOL functions, that's Conway's Game of Life functions. So let's see here, headers. We've got a few functions. We'll talk about the yield one in a second. I forgot to mention that when you look at this stuff, let's run the executable here. It actually, this world, the way I designed it, it wraps around. So once you go off the right side, you appear on the left side. You'll notice certain structures like these squares up here. You see there's a square here at the top, and it's also down at the bottom. So these, once it forms a little square, as long as that square is not disturbed, it will just remain. Not a bigger square, but a 2x2. Yeah, so the world wraps around. I call that Atari world wrapping or something like that. Atari game world. Okay. So for yield, what this function does is it simply checks, basically, because we have to get the neighbor cells for Conway's Game of Life. So for example, we might, we'll see it later, but the yield so we might go into more detail here, but yield is basically going to check that the x or y, the x and the y value are inside the world, and if they skipped outside of the world, then it wraps it back around, if that makes sense. We got an x from I, so the I, you know, because I iterate this, we've got this pointer to, I think of these as arrays. I know it's just a pointer, but I think of these as an array of cells, and then we have a copy of this. I'll just call it an array, even though I'm technically incorrect. I mean, arrays are pointers also, so in C, so whatever. Yeah. Okay, so let's get into it a bit. We've got some random. This creates a seed for a random number generation. The initial conditions are determined randomly. I'm not sure if this is being used. We'll see later. So I haven't cleaned out everything yet. Cells is malloc, so we're mallocing for this. So both of these need to have some memory allocated to them. So we do that. The size of the cell and the screen total num tiles int. So yes, this is getting used then. And let's see here. I bet that is, yeah, that's being declared up here. Defined, I should say, right? Anyway, sometimes mix up declared and defined, but yeah, so it's going to multiply those to get the total number, and later we have this in float. Sometimes it's useful, but this will determine the total number of tiles, right? The width times the height in terms of tiles. So it's a little ambiguous, the name of the thing. I could rename it, but whatever. Yeah, so that's the number of cells that we need to allocate malloc for. And so we do this, you'll see this a lot, these for loops where we're doing this, the number of total tiles. So this will do once per cell, basically. And yeah, and it's iterating through this array. Okay, and so it's setting is alive randomly to, this will actually set it to 0 or 1. That's the way this works. Because, right, we're doing modulo 2, that'll give you a 0 or a 1. Now, what's next? Same kind of thing for this for loop, but we are sort of initializing your x and y values. So we have this get x from I, get y from I. So that's why it says from I, right? We've got these, the I is basically iterating through all of the members of an array, basically, elements of an array. Anyway, and then I just set it for the .trans IVEC. Okay. I believe that must be an IVEC, right? Yes. Cells copy, we're just going to do the same thing. This is boring, it just makes a copy because you're going to see later why we need a copy. Obviously commented out. This is irrelevant because I'm not taking arguments. Now this is all Windows stuff. Okay, I've talked about that in previous videos. Don't really need to talk about it here. Input is not being used, but I haven't removed it because it might come in handy. We set up a VAO. That's pretty boring OpenGL stuff, but yeah, this is in OpenGL, so I'm not going to go through everything. Most of this is not getting used. I could probably comment out everything, but I think colored quad. Let's see here. Got a bunch of different shaders. Yeah, that's the one that's being used. So let's see. Sorry if I comment all these out. And I believe it's gonna bite me down here. Let's see what happens there. Yeah, it runs fine. All right, then blend. Yeah, this is alpha and not really necessary. I don't know. you know, a lot of people, and I might significantly clean this up, but you know, like you've got the input and output stuff. Somebody might want to use that stuff. So it's kind of up in the air whether I should, I mean, input and output as far as like keys, the mouse, etc. It's kind of up in the air whether I leave that because somebody, including myself, might want to add to use it, or do I, take it out because it'll make the code cleaner. Yeah, I might go either way with that. I will make a cleaner version. This is frame buffer stuff, but there's a sort of a default frame buffer that you get with OpenGL, and I'm not using it here. But again, it's another thing that, maybe will come in handy. Yeah, so now we're just saying to use that shader before. The shader is really simple, so let's take a look-see at it. VS and FS. This is a very common thing where you multiply times scale, and you have translation here. So not transform, but translation. And yeah, so it's fairly straightforward. And then lots of commented out stuff here. I'll just erase this part. I think this was from a tutorial I was doing before. And so we're just passing in color. So you do notice that the colors are different here, right? There's some color based on the X and Y position. So we'll see where that's being passed in later. And yeah. So fairly straightforward shaders there. Yeah. All right, we get time. Not sure if that's even been used. Different types of time. Window size GL viewport. I've talked about this before. It's about adjusting the size of the window so that everything is kind of logically making sense when it doesn't like move around while you're adjusting the window, if you will. This was important. I was struggling for an hour or two thinking I had a bug. Well, I did have a bug, and it was just because I had commented this out. And so what happens? Let's watch what happens if we're not clearing. What happens is once something is drawn, it's drawn and it's there forever. So wait, sometimes it's becoming dead again. That's kind of strange, mysterious. But we definitely need that to clear it out so that we clear it and then we redraw all the living ones afterwards, if that makes sense. If we don't do that, the living ones will, once a cell is alive, it'll stay like it's alive. All right, so this is iterating through for every cell, and we get the neighbor counting stuff going on. So we've got an int neighbor count, we initialize at 0. We've got, now the copy is going to be important. Here's why. Let's say I'm going through and let's say I didn't have a copy and I'm on the ith cell, so let's say the 12th cell or whatever. I count its neighbors. Based on it, I change it from being alive to dead, and then I go to the next one. Well, when I go to the next one, now I changed that previous one from alive to dead. So now when I count the neighbors, I'm going to count that previous one as a dead one. See? So you're messing with the data while you're trying to calculate the next stage. And so you don't want that. So we calculate every cell, whether it should be alive or dead, and then we fill the copy with that information, then we swap the data afterwards. Okay, I hope that makes sense. So we start with it dead in the copy. Okay, everything, so it'll go through every time it starts with a cell, it'll start as dead, okay, in the copy, that is. So now in all these, we're looking at all these cells, right? So this is not the copy, this is the original. We get right, get left, get down. So it checks all these, and if it returns as +1, which represents true for me, neighbor count plus, okay. So we're counting the neighbors, and that's what you need to do for Conway's Game of Life. So we'll look at some of these, get right, get left, all these, fairly straightforward, but it's made easier by the yield function. Part of why I like having this Atari game world that wraps, it makes it easier for me to make sure that I'm handling the edges correctly. Because like you saw, there's certain structures like the little squares that could exist you know, from one side of the world to the other side, right? Kind of split across the top and bottom or left and right. That tells me that I'm dealing with the edges correctly. It'd be nice at some point if I could catch it in the corners, like each corner had a dot there, would mean that there's a little square structure that's existing in all four, you know, split up on the four corners. That would verify to me that this is getting calculated accurately. But see, if I don't do something like this, then how do I know I'm handling edges correctly? It gets a little tough to determine, to verify visually that it's being handled correctly. So I kind of prefer it with this yield, although I think maybe it does make the coding a little more tricky, but yeah. So, but it makes these functions a lot easier. So you get up. Okay, so let's look through one of these functions. So we take in the input vec. So it's taking the input vec of the original cell for all of these. We're not messing with the original cell and then getting the information. We just say, for this cell, get right. For this same cell, get left. For the same cell, get down, and so on. So it takes that original cell vec, ivec2, and so first off, we make a new ivec2 with the modification that we need. So this is getting up, so we're going to add +1 to the y. If it's get down, we subtract -1, and so on. If it's get upright, we do +1, +1. Logical, right? So we have a new ivec2, and then it checks it with the yield function I talked about earlier. So this will check the x and y values, and if they're off, it will correct them. So if it goes over the board in either of the four directions, it will correct for that. So we get this. So this is being done to new ivec2, so its data is being altered. Then we just get the I from x and y. So this will get us back the I because, yeah, we need to get that I. We don't use the x and y to determine, like for the cells array, I cannot pass an x and y in there. I have to pass in an I. So we just get the I from the x and y values. It could say get I from ivec2 might be, you know, more accurate, but where is that function anyway? It's right here. Yeah, it's what it sounds like. So we get that I for the new I, and it returns whether it's alive or not. So it checks the neighbor above is all it's doing. But before that, it does the yield thing to correct it in case it's on the edge. Then we get back the new I based on the correction, and whether it corrected or not, we get the new I and check. They all have the same structure. The difference is going to be here. Okay, so yeah, that's how those work. Somewhat straightforward. So we check all those neighbors like that, and we have a neighbor count. And while I was making all this, I was debugging. You know, if you're going to do this, just because Conway's Game of Life is a great thing to do if you're doing, like, let's say you start up in some language that you're learning a language. It's a great thing to do. It can be a little challenging. Like sometimes dealing with this grid, and if you're trying to do the Atari's Game World stuff, maybe start by not doing that. Don't worry too much about your edges, but I think it'll be easier that way. Yeah, it's a nice little challenge, you know, after Hello World and some basic applications, assuming you have access to a graphical interface like this, it's a nice way to get acquainted with a language, I think. Okay, and anyway, I was going to say that when you start with just what I did anyway. I started with like the cells get determined randomly, and then you just let them shift to the right, for example, or shift to the left. So if it shifts to the right, that means that you're checking the neighbor to the right. So you would just do only the get right part, and then if the neighbor count is 1, then you turn it alive. So does that make sense? Everything will shift to the left or the right, depending on which way you do it. Same, I did it up and down. I did all this before, and also the diagonal directions too. I wanted to make sure all these functions work the way I think they're working. So I just had a world where everything is just moving to the right or left or diagonally in one direction. I checked all of them, and that's why I have all these prints as well. I didn't get it right the first time. I made mistakes, and you have to fix them. And then these 2 lines right here are actually the Conway's Game of Life, all just in these 2 lines. If you read it, do I have a README here? Here are the rules. You can stop the video and look if you want to see the rules. But you can actually condense them even further because you can be condensed into these 2 lines. And I mean, the way Conway's Game of Life looks is pretty distinct in the sense that you've got these, you have floaters that develop. You've got these similar structures that pop up, like the squares, like this one over on the left. It got destroyed. You see, there's a floater at the bottom. In the middle bottom, that's called I think it's called a floater. It's making its way across, and it's going to hit that, hit that thing, and it explodes. Oh, into those like flower petal type thing. Yes, these kind of structures are very familiar. So, I can look at this and see, well, I got it right. I got the rules right. I can tell by looking at it. Okay. Then we're switching these, we're just switching the copy to the new one, or sorry, to the original array, if that makes sense. And what is this? This is the rendering, I guess. So again, this is going to be every cell. It's going to iterate through every cell. We've got int x, y. Now, I had something before where I just had a grid. I was just rendering a grid, and I didn't have the cells. Like here, I could go through cells and I could get the x and y. I don't need to make this calculation, but it doesn't really matter. This was already here. I'm getting some kind of x and y. There's a width that is being calculated dynamically based on screen width and height. Remember, the screen width and height, that's counting in terms of tiles or cells, and we had the float versions of that for this. I think if I put the int here, it will make a float. I forget. I just try to keep my types. I don't try to do an implicit typecasting. I try to be explicit. And all right, then let's look at this. So we've got the draw. Okay, if the cell is alive, we're going to draw the 2 triangles. This is 6 vertices, 2 triangles. It's a quad. So we've got these 3 uniforms. Okay, scale, that's the size. All right, that's getting calculated here. Translation, well, it's a little beyond the scope of the video to like dissect all this math. It's basically, I mean, I started with a grid. So before you dive into making Conway's Game of Life, work on making a grid. You've got X and Y, but you're iterating with this I value. So that's a good little challenge. For those who are not mathematically inclined, it might be a little tricky. So if Conway's Game of Life is mathematically too tricky for you, I wouldn't worry about it. But for those who are not shy of math, I think it's a great little exercise to do. So yeah, I'm not going to dissect it completely, but now the color here, I could just set this to something very specific, like, this would be red if I do, because it's RGBA, so if I did red, I would do like this, right? Last one is for the opacity, and this would be red if I, you guys know this, I think. This would be green and blue. So by making this variable, okay, based on width and height, you just get some interesting stuff. Let's try, if I divide this by 4 instead, what's it going to look like? Some of them might not appear, so it just looks darker, yeah. You know what, the width and height will be, I don't know, I'm too lazy to think about this on the spot here. I should really think about what kind of range you're going to get for these values. It looks like you're going to get small numbers. So I think I could yeah, I could toy with this a bit and get like a more vibrant range of color. That might be a good thing to do. That's basically it. Oh yeah, I have this micro sleep, so it's in terms of microseconds, so it looks like 100,000 microseconds. This is so that, I mean, if I take this out, it's gonna go, actually, I want to show you, but I think it might mess with the recording. So it will go super fast, though, too fast. And then this is standard OpenGL stuff. We swapped the buffer, and yeah. That's pretty much it. This other stuff is not getting used at all. Check collisions, none of this is getting used except for setting up the VAO. That's other stuff that you can see my past videos if you want to see that. So that's it. This is a quick overview. Yeah, like I said, I'm going to maybe adapt this a little bit for, I think this is very close to working on Mac OS and on Windows. We don't have the syntax highlighting here, but I think it should have batch file. Yeah, batch file. Although I'm using Echo. Well, you can on Windows these days. But anyway, basically this might work. Let's see here. We're not using some of these libraries. Actually, I think we are. Yeah, I think this might be okay. And then I think these might be okay. I just need to test them. Might need some small modifications for you doing this on Mac or on Windows, and I'll get code. My plan is to get the code cleaned up, make it a bit more organized, think about how to present it, and maybe make some cooler videos on Conway's Game of Life. There's also, if you're interested, this program called Golly. I have it installed, but if you check it's cross-platform. I'm not 100% sure it's on Windows, but I imagine it is. And yeah, a simulator for Conway's Game of Life. So you can easily toy around with Conway's Game of Life using Golly. So that's kind of cool. Anyway, more videos to come, and thanks for watching, and stay tuned. Bye.